Okay, my name is Kanti Bhabuthmal. I am from Supermicro. I've been with Sun Microsystem for about 20 years, and then Sun got bought out by Oracle, made my transition over to Supermicro. At Sun, I used to be a Spark microprocessor design engineer. At Supermicro, I'm part of the marketing organization. Why am I here? What can I help you with, or what can I offer? The reason is, in the last 1 year, I've been working with a lot of our sales teams trying to look at RFPs from different organizations across the globe. And I thought I could spend some time with you talking about what Supermicro is doing in terms of hardware and some of the cooling techniques that we are using with our partners. So that's kind of my 30 minutes in front of you. Feel free to ask me questions, but let's not derail the meeting because I only have 30 minutes. Or we can obviously take it offline. Sounds good? Okay, so from an agenda perspective, I have 3 slots. The first one is I'll just briefly touch on how I view RFPs. What comes to me as an RFP, and what are the key points that I see in any request for proposal for an HPC solution. The second part is about some of the success that Supermicro has had, some of the installations we've had. And I'll try to match those with our products and the cooling solutions that we've used. All right. We have about 8 mentions in the top 500, 18th being the highest. It used to be 13th last November. And we have 3 references in top Green 500. We do have more references which are not listed because most of them are through our OEM projects, our OEM customers. And then lastly, I won't spend too much time, but I'll do highlight a few products from Supermicro. All right. So when I was thinking, how I should start, I looked at all the different RFPs that I got, whether it was Saudi Arabia, whether it was South Africa, or whether it was Mexico. The 3 things that always came up very loud and clear, right? The power, performance, and price. Typically, I would get, say, we deal with medium, the small to medium HPCs, so we don't deal with very large HPC requirements. We would get something like a petaflop of performance, but the power requirement would significantly drop. It would be like 600 kilowatts to 800 kilowatts. That would be a very daunting task, right? So you are giving me a performance that is 1 to 3 peta, and then you're giving me a power number that is way low. It seemed impossible. It seemed very daunting, very challenging. But once we started looking at newer technologies and mixing and matching, different options we had, it seemed like, okay, we can arrive to it. However, affordability and price would also come into play. So then that would be a different challenge. On top of that, everybody wants, interconnect, the best interconnect. They want, non-blocking type of interconnect. Pricing again comes into a factor. Then we again look back into what is the performance that they require, and then be able to provide those. And lastly, but not least, form factor, right, or the floor plan. Typically, these are not new HPC installations, new data centers. These are existing data centers, but they want to scale up, or they want to add stuff. So in that case, again, they say, here's your budget, right? You have, 10 racks, 15 racks, go fit into this. So those are, some of the challenges, we face, and we're able to, overcome, most of those challenges. And so let's go to the next slide. The next slide is about, some of the drivers and the trends. And I'm thinking, these are absolutely, not, blazingly new things. You probably have, seen this before. Number one being, server nodes. Most of HPC that we deal with are the blade architecture. So that's a 7U, 9U, or a 10U, up to 20 blades. But we also have, the racks type of architecture, the horizontal ones, where we've gone and, increased the rack, the node count from 2, 4 to 8. So the challenge there is the power, right? You can have a very dense, type of server. However, once you fit it into a 42U rack, you still have the challenge of, hey, do I have 20 kilowatts or 30 kilowatts, and can I, cool that? Can I, have that many, racks, that many servers in one rack? So that's a challenge. The second one is the number of CPU cores and threads. CPU cores have also increased, right? So it used to be, 2 core, 4 cores. Today, Intel has 18 cores. So that means, you have 36 threads. Not so much of a challenge for me, but for, people who are doing, software parallel programming, they need to, keep in mind that, the core count is growing. So they need to have, better tools, do better parallel programming. There is obviously another, challenge, between these two. Remember, we also have virtualization. HPC typically has a pretty good efficiency when it comes to compute, but don't forget that, we had the liberty where we said, oh, you're going to buy, 20 racks, but, your utilization typically would be, 30, 40%. That's typically data centers. HPC utilization is a little higher. But with virtualization, you got to remember that utilization is also going up, which means you can't over budget or over provision for power. You have to be careful. The next one is GPU, with the number of cores increasing. NVIDIA just announced their K80. If you're familiar with the Tesla GPUs, same thing with Intel 5. You get 1 to about 2 teraflops per GPU. So Supermicro actually has GPU type of solutions where you can go all the way up to 6 GPUs in a 2U server. So that adds up a different challenge, which is how do you manage thermals and power. But then you also have the challenge of application porting, because now you are dealing with a hybrid. A lot of HPC requirements that I get, they would specify saying, I want 60% CPU only, 40% CPU GPU combination. And sometimes we say, can you stretch that? Because you don't have to add another server. You add another GPU card, you get higher performance, right? So we played those type of I wouldn't call it tricks, but we go back and forth on the technical discussion on that. A couple more things on the bottom: internet, connectivity. So this basically again goes back to we had 10 gig and 40 gig. We're now approaching 10 gig on the Ethernet side. Similarly on the IB InfiniBand, we've had QDR, FDR. Very soon we would have EDR that will take us back to 100 gigabits per second. Again, there's a big cost associated with it. People like to have non-blocking interconnects, but got to be cognizant that there's a cost associated with it. On the storage side, nowadays, you get a very specific, storage node requirements, and there's a storage performance requirement also. Although we've transitioned to SAS3, there's still always the question about performance, protecting, and also making sure that, in case of a failure of a drive, that you're able to recreate the drive very quickly or transition to a secondary drive. That's still a big question mark. Although I think with object storage, that's becoming less and less of a concern. Lastly, we also have to look at energy efficiency. So I'll speak a little bit more about all the things we are doing also in terms of how do you control power usage both to the servers and also power coming, power into the data centers for the cooling purpose. So those, I think, are the trends and the drivers which we are constantly facing. There are some other emerging technologies also that we at Supermicro are embracing today. These may not be directly applicable to HPC as of today, but we've seen that people would like to take a look at this, see if these would fit into the HPC model. I did talk about node density, but we do also have other multi-node systems where we can go all the way to 112 atom nodes in a 6U, or 28 nodes in a single or a double precision, or single or a double CPU type of server. So obviously this one has the same challenge that I mentioned, which is power, right? You get a higher density, but you also have to deal with higher power densities. Power supplies typically pretty inefficient. Now we transition from platinum supplies to titanium. Titanium supplies are about 96%. So as you can imagine, if you have servers that are idling, you are not draining too much or wasting too much power because you got pretty efficient power supplies. They're almost approaching the digital supply type of efficiencies. For some applications where they are looking at higher L3 caches, there's this new technology called ultra DIMMs. Basically, it's an RDIMM, but behind the RDIMM there is a flash. So you get about 200 to 400 gig SSDs, but these are on your actual DRAM slots. So thereby you get a higher memory count. Again, HPC, sometimes you are not really looking at this high depth of memory, but I'm sure there might be some applications that would want to look at this. Again, from a price perspective, this is very economical and also something we'll be proposing moving forward. On the storage side, there is this thing called NVMe, which is SSD on PCIe. It's a new and upcoming technology. Intel is driving it pretty fast and hard. The price is dropping. SSD prices or NVMe prices approaching SSD. So for sake of people who are not familiar with this, this is basically SSD without a storage controller, right? Like a SAS or a SATA controller. It talks to the PCIe bus direct, which means you have a CPU to SSD direct connection, and thereby it gives you about 6 to 7x performance boost over your traditional SAS or SATA, both from an IOPS and from a bandwidth perspective. So that's clearly something we are promoting right now. Of course, HPC market might be slow to adapt. Moving on, battery backup. So I say no UPS. Basically, if you have a server, of course, if it is an existing data center, you already invested in UPS, this may not come in handy. But if you are building out a new data center and you are looking at UPS investment, BBP may be an alternate solution where it has the exact same form factor as a power supply, and you might have an N+1 or an N+1 power supply combination, but you also add BBP. The BBP basically will provide 2 to 3 minutes of power in case of power failure. So you're basically protecting your data similar to a UPS. It's not a backup generator by any means. It's just a matter of graceful shutdown, so you save your data. But it's, again, from a cost perspective, way, way, way low. So battery backups, no UPS, another trend we are seeing. Lastly, the cooling system. So traditional data centers use air conditioner, right? And now they're moving into liquid cooling. So there are multiple ways of doing liquid cooling. In the next few slides, I'll specifically talk about the different companies that we are working with, different installation and successes that we've had using liquid cooling. So far, so good. Okay, there's three different techniques that we'll touch on. The one is traditional chilled water, but using a chilled door or chilled water door system. The next one is called a direct-to-chip heat exchanger. Our friends from Cool IT have a booth here, and they have a setup to look at. We also have this thing called liquid immersion, also sometimes called as submersion technology. So I'll talk about all of these three. So before I start, I just want to also mention that this is your traditional AC backed cooling system. This is what most of the data centers currently have. The orientation is you have a hot aisle, cold aisle, and then there are lots of new techniques that come of how to capture this hot air and be able to keep the data center cooling expense to a minimum. Supermicro does also have what we call as our fat twin servers there, just to help the data center and the HPC folks front I/O and back I/O. So in case you don't want to work in the hot aisle, we have servers that have front I/O. So basically you don't need to get into the hot aisle. You work on the servers from the cold aisles. Okay, so of the three solutions, the first one is chilled water door cooling system. So in this case, you actually have, this by the way is the most reasonable in terms of cost. Most people like this type of solution. It's easy to implement. With liquid, most of the data center folks, most of the HPC folks, they're reluctant because they do not want to get liquid into anywhere close to the electronics, right? There's always this fear that it's going to leak. It may have other implications. Anybody saw the ad at Super Bowl from the Coke ad? Yes? No? Yeah. So what did you think? You thought it'll freeze the server, right? It ended up into a different ad. Okay, sorry, I had to make that joke. So back to where I was. So this one actually is, it still uses the existing chilled water infrastructure, except what you do is you replace either the rear door or the panels, or it can be modular, depending upon your server power densities. So what you do is you replace either the most efficient would be is replace your back panel with a chilled water door. So basically what it is you have modules or a door itself that actually captures the hot air, right? So you're still maintaining circulation of hot air, of the fans and the cooling system, but you are minimizing the hot air distribution into the data center. So you're capturing most of it. So you have the airflow from the front to the rear, and then you have the chilled door that blocks or captures the hot air, and then it feeds back into the chilled water compressor system. So from an economics perspective, this is by far the cheapest, easiest to implement. They've claimed that they can actually do a retrofit within a day and stuff. So as an example, PNNL is one of Supermicro's installations. This is ranked 18th, as I mentioned before, was ranked 13th. We have 3.4 petaflops. That's about 14 nodes, 20 or 2008-80 Intel dual processors with GPU. So it's a GPU, CPU hybrid combination, and they are using the chilled water, cooling system. So they maintain an ambient of, 48 or 78.6 degree Fahrenheit, about 25 degrees centigrade. So from a cost perspective, they are looking at, 2 to 3 years of OpEx savings to make up for, the capital expenses that they've incurred to retrofit all of their servers with rear door cooling system. Okay. So the next cooling system is the liquid cooling or the DCLC, also known as the direct to chip. So in this case, what you're really looking at is a server without heat sinks. So the heat sinks are actually being replaced by a dielectric system that has, fin-based system. You can take a look at it when you go into the exhibit hall. This system is then, hooked up to a manifold and then hooked up to a heat exchanger. So this is a self-contained single rack. There's no other connectivity. Everything is self-contained. So this is, again, becoming, pretty popular. There is redundancy built into the centralized pump, because that's probably your, biggest failure point. As far as the cabling and the piping goes to the individual components which have heat sinks, those are tested at pretty high PSI, like 250 or so. So you can be sure that there will be no leaks. Again, the bodies are all either galvanized or some kind of non-corrosion material. So you are they've covered you on that. So this is a self-contained AHX system. The next one I'm showing you is more of a data center. If you want to have a centralized unit, so this one actually will support, say, 10 to 20 racks with a capacity up to 750 kilowatts. So again, this one depends, if you are ready to make that investment, make the transition to have a, you want to get your entire data center to change over. So one thing here is your electronics or your server has to be modified. So people do have that concern that, oh, if I do modify and if there is a failure, service can be an issue. Only 5 minutes? Oh my God. Okay, so I have to speed up a little bit, I guess. So this is one example. It's called Cherry Creek. We've shown this in many of our supercomputing shows. We've actually taken the demo over there. So also we have, like I mentioned, stuff here in the exhibit hall, so you can take a look. So let me, speed it up a little bit. The last one that I have is the liquid immersion or the submersion technique. In this case, again, you have to retrofit the servers. You actually take out any of the casing, you take out all of the heat sinks, all of the fans, there's no moving parts, even hard drives are either enclosed or you change them over to SSDs. And on top of that, you just have to add a dielectric on top of the heat sinks. So there's a heat exchange type of material here. So it's basically a tub. You can fit a 42U rack instead of vertically. You fit it horizontally into these tubs. So there's a dielectric liquid in the tub, and then there is a pump that pumps in and circulates the liquid, And you also have the heat exchange through the chilled water. So this is basically your existing infrastructure. This is your new stuff. So again, from a data center perspective, if you do have racks installed, yeah, you got to go replace it. But again, from OpEx, CapEx perspective, this is probably your best bet in terms of cooling. But like I said, you have to know what servers you're going to use. You have to replicate those servers. You have to get those servers modified. But it's actually something that a lot of people are taking a look at. So this came from Green Revolution Computing, Green Revolution Cooling. There are a couple more companies that offer this type of solution. So I do have one example, which is the Vienna Scientific Center. They did, or Vienna Scientific Cluster. What they did was they took 2 motherboards, removed the heat sinks, and so what you get is a better density, plus you actually have less than 1 U. So you can actually have in a 42 rack, not just 42, but more than 42 servers. So you get a better density out of it. The other example is CGG Veritas. It's a huge Houston-based company. Again, this one actually has both servers and GPU combination. The other thing is Supermicro actually does full warranty. So that's another added benefit that we provide. Another example is the Tokyo Institute of Technology. This was the first time where an x86 implementation made it up to the top. So this one had a PUE of 1.05, 6 gigaflops per watt. What else? So it did have the top 500, #1 listing last November or November 2013. So that's kind of where I wanted to show different examples of our cooling technology. Give you a little bit background of Supermicro. We've transitioned, from just being a component subsystem company into a full server, and now we actually provide, full service support and solutions. So you can talk to me later about, what products we have, and I can give you a lot more details. Giving you a few examples, this is our Ultra server. It's a brand new server. So instead of using, general purpose servers or data center optimized servers, what we have is a very unique architecture where the CPUs are side by side. Memories are also side by side. So that's one. So your cooling and thermals are better. Number 2, it supports, the 1U supports 4 add-on cards, and the 2U supports 8 add-on cards. So effectively, you can get 4 GPUs here and 2 GPUs here. You also have pretty high memory density, 24 DIMMs. Typically, you will get 8 or 12 DIMMs. In this case, you get 24 DIMMs. Plus, you get 24 hot swappable 2.5-inch drives or 10 2.5-inch drives. Plus, in this case, you get the titanium supply. We can obviously also upgrade this from a platinum to titanium. On top of that, some of the drives can be NVMe drives. So this one server basically, is kind of a fit-all, be-all type of server. So that's our new architecture. E-Phi 2600 is a dual processor. It's the Xeon DP. So basically, our 2 processors, 1 and 2. Somebody had a question or a comment? Oh, okay. Sorry. Okay. Also on the multi-node, like I'd mentioned before, we do have 3 lines of multi-node servers, or what we term as the MicroBlades. You have either 112 nodes of atoms in a 6U, 28 nodes of E3-1200. This is the low-end Xeons, single processor, 28 nodes. And then you also have E5-2600, 28 nodes. So as you can see, there's a pretty good density here, and it has built-in switches, so you eliminate any type of cabling. We do also have SDN on these offerings on these chassis. But one thing to note is power, right? So if you have such density, you are going to obviously have redundant power, and also the power envelope is going to be quite significant. So therefore, you may not be able to fit as many 6U boxes in a 42U. You can't overload it. Also, we do have MicroClouds. These are again either you have a E3-1200 24 nodes, E3-1200 12 nodes, or E5-2600 with 8 nodes. So dual processor, single processor, either 24 or 12. The reason there's 12 versus 24 because you have more capabilities, plus the wattage can be higher, although in this case it's both 80 watts. You also have 10 gig support, plus you have space for add-on cards and higher hard drive capability. In this case, you can get up to, in both cases, you get 4.5 and 4 2.5 inch, 4 2.5 inch. All right. So that's just a brief introduction about some of the high multi-node servers from Supermicro. Happy to again answer any questions. As a summary, I think we all know that energy efficiency is of the prime importance. Power and performance are a big piece.